Hey, welcome to my performance test on an Intel NUC 7i5DNHE, which is the latest Intel NUC in spring 2018. So in my last video I recommended to use NVMe to reduce the CPU load during storage operations. In this workshop you'll see how much performance can be gathered out of an NVMe in Intel NUC. So all storage vendors have these fantastic numbers on their product specification template like Samsung do. And yes, Samsung NVMEs are the best choice for your server platform. I really like the price and performance of them. They are also a really good choice for every system that need high storage performance. So performance is a very difficult thing, and it pretty much depends on a lot of environment factors like chipset drivers, CPU, operating system, or even the temperature you're running the system. So this test is focused on Windows Server 2016 on an Intel NUC. Latest chipset drivers and latest updates on the operating system. The next interesting point is that the only performance that really matters is the worst case scenario, and that is random writes. All other tests like sequential read or random read will be affected by the operating system running the test on. Even when we force to not use cache, the operating system is intelligent enough and will support and bring in intelligence into the read stream. I use disk SPD from Microsoft to test the system performance on the storage. The link can be found in the description of this video. I built a PowerShell script around disk SPD that will go through different block sizes and different threads and QDEV. So to show when a system goes into saturation and into high latency. This is a perfect test to see where the performance frontiers are for the storage in your system. My favorite block sizes are 4 KB because of any metadata changes on the file system, 64 KB block sizes because of Microsoft recommendations for SQL and Exchange or Hyper-V, and 256 KB because of backup products like Veeam and large file copies. For file system I use ReFS. My monitoring is running on Grafana and the Influx database. So we have a deep insight what is going on the storage. By the way, I use this method during consulting sessions at enterprise customers, and no one has a comparable solution in place that have a 10 seconds interval phase. So this can be a very helpful tool when you start analyzing your customer environments. So let's take a look at Grafana, and at the beginning we have got 50 megabytes per second transfer, but a very high disk IOPS. So this is related to the 4 KB block size. And the next hop to the 64 KB block size will result in lower disk IOPS, but in higher megabytes per second transfer rate. And the next step was from 64 KB to 256 KB. So even here the disk IOPS went down, but the transfer rate stayed at the same level. Conclusion of that is that we've got that we reached the maximum bandwidth of our Intel NUC. During building the queue length and creating more pressure with threads, we've got the raising average disk queue length. So it doesn't matter if it's 4K, 64K block size or 256K block size. But we see a difference in the average disk latency in milliseconds. So at the 4K block size we've got no latency, and the latency raises in extremely during the 256K block sizes. Thank you for watching earlyadapter.me. If you like my video, please give me a thumb up and subscribe my channel.